Alright, welcome to the video going over the Chapter 8 practice test. Feel free to skip, fast forward, rewind, whatever you need to do to make sure you are ready for the test on Tuesday. Alright, first thing is 8.1, and that's the Pythagorean theorem. So everything in here is a squared, b squared, and c squared. Alright, so the most important number one thing is to know which one is your c squared, so where is the hypotenuse. So first thing that I always did with my groups is find C. It's across from the right angle, okay? Then it doesn't matter which one is A or B. We have 12 squared, we have 16 squared, and we have x squared. We also talked about Pythagorean triples, and this is one of them. So if you recognize it, then you can skip some of this work, all right? But we have 144 and 256, adding to 400. All right, the last step should always be taking the square root and seeing if it's a perfect square or not. This time, 20 is that hypotenuse for number one. Number two, we have 14 for C. All right, when we start to show work on this one, we have x squared and 13 squared as our legs, 14 squared as the hypotenuse then. X squared stays the same, 13 squared is 169, and 14 squared is 196. So the next step would be to subtract the 169 over on both sides. This time we have x squared equal to 27. All right, if you take the square root of 27 in your calculator, you will get a decimal out. So we're going to simplify the square root by pulling out a perfect square. The perfect square of 9 goes into 27 3 times. So our final answer here is x equal to 3 square root of 3. Okay. Number 3 here is another perfect square. It's another Pythagorean triple, I should say. We go a different color. 61 is going to be your hypotenuse. So we have x squared and 11 squared adding up to 61 squared. All right. 11 squared is 121. 61 squared is 3,721. When we subtract over, we end up with the square root of 3,600. This time, you don't get a decimal when you punch that in, so we have 60 as our final answer for that one. All right, that's going to be your basic Pythagorean theorem. If you get a perfect square, awesome. If you don't get a perfect square, simplify that square root down, simplest radical form. Okay, these ones are talking about acute, right, or obtuse. So what we need to do is compare. So we still find the biggest number as our C. The best thing you can do to help yourself for this one is put C first. So my classes, we talked about 41 squared being the first thing that you write down. And then we're making a comparison here. So we don't know what to put, if it's an equal sign or a greater than or a less than. That's what we're checking for this time. So that's going to be what I start with, just putting a box and filling it in later. So now we have 9 squared and 40 squared after. I'll figure out what to put in the box after I do some of the math. If I put an equal sign, it'll be a right triangle. Greater than would mean obtuse and less than would mean acute, as long as we're set up with c squared on the left. So 41 squared is going to be 1681. We're going to check that, compare it to 81 plus 1600, squaring those two numbers. Okay? So what's going to happen this time is we're going to get a 1681 on the left, a 1681 on the right, so I would put an equal sign to replace my box there. All right, which means if I'm putting an equal sign, I have a right triangle. All right, so if they're equal to each other, they are right. 20 is C for number 5, so I have 20 squared. I don't know what to put, so I'll put a box. We'll go 10 squared and 16 squared. All right, we're comparing 400 to 100 plus 256. All right, so 400 compared to 356 is bigger, so I put a greater than sign, which means I have an obtuse triangle. All right, lastly, number 6, 18 is our hypotenuse, so we're going to put that first. We're comparing it to 12 squared and 15 squared added up. So 18 squared is going to give us that 324. We're comparing that to 144 plus 225. So 324 compared to 369 is smaller. So we're going to put a less than sign, and we have an acute triangle. So that's every possibility you could get. Equal, greater than, or less than, and then the decision that you make with each. Okay? Pythagorean triple problems. These ones are set up not in the most generous way for you, but what we're trying to say is what's the number that goes with 33 and 55 that's not a decimal that makes a right triangle, so that a squared plus b squared does equal c squared. All right, if you do this first one, and 7, 8, and 9 are all the same this time, as far as we're going to assume for the first part that they did give us A and B, but that's going to end up being false. So the first thing that we could try is the number that we're looking for bigger than those two. All right, we end up with 1089 and 3025 equal to x squared. So then we're looking at the square root of 4,114, which is going to be a decimal. All right, so we know that we made a mistake here. We can't have a decimal as part of our answer. So we're going to kind of start over, all right, and we're going to say, okay, maybe this one was C, all right, the number that was the biggest. That must have been C. And that happens for all of these. It's just the way that it works out. 58 is C for 8, and 65 is C for 9. So sometimes they give you the hypotenuse, and you have to find something in between. So actually for this one, it sets up a little bit differently. It's 33 squared. So that, starting kind of over here, 33 squared plus x squared, what we don't know, should equal 55 squared. All right, if you do that, we're going to be looking at x equal to 44 for that final answer. Okay, so we'll do some more of that. All right, but really what we're looking to do is to make sure that we're finding a number that's not a decimal that goes with the 42 and the 58. All right, so this time I'll show a little bit more work. I'm just gonna tell you right now that 58 is definitely the hypotenuse, just because to save some time. All right, I'm just going to tell you that piece of information at the beginning. So we have x squared. When we square 42, we get 1764. 58 squared is 3364. So when we subtract 1764 over from 3364, we get 1600. So if we take the square root of 1600, we get our answer of x equals 40 for this one. Okay. Same thing's going to happen to us over here. I'm going to tell you 65 is C, so x squared plus 60 squared has to equal 65 squared. So we have x squared plus 3600 squaring 60. 65 squared is 4225. We have a subtract step and a square root step. So when we subtract, we end up with 625, and the square root of 625, that our answer is 25. Okay, one more Pythagorean theorem, and then we'll get to our shortcuts. A town recreation hall needs to build a ramp. The height of the ramp must be 2 feet. The ramp will start 6 feet from the door to the nearest tenth of a foot, so they'll tell you how to round. The question is, how long will the ramp be? So that's going to be a hypotenuse. Let's draw a picture. We have a ramp going up to a door. We know that it has to be 2 feet tall. We know that it's going to be 6 feet. The ramp is going to start 6 feet from the door. They're asking how long is the ramp. They're asking for the hypotenuse. So if it's the hypotenuse, we have to make sure we have 2 squared equal or plus 6 squared equal to x squared. So this time we have 4 plus 36 equal to x squared, or we're taking the square root of 40. We would look to see if we could simplify that down with perfect squares, but they want nearest tenth. So when we punch in the square root of 40, we get about 6.3 feet. That's how long the ramp will end up being. That's it for Pythagorean theorem. Feel free to rewatch any of those things here. All right. Moving on, we have the 8-2, which is all of our 30, 60, 90s and or our 45, 45, 90s. So what you need to remember about these is the shortcut. So if we have a 45, 45, 90, that means that we have a right isosceles, which means the legs are the same length. So we had a little shortcut. If this is the hypotenuse and we're going to a leg, we would divide by square root of 2. So these are shortcuts. They're intended to be fast, but we have to make sure we answer in simplest radical form, so no decimals right now. All right, x is going to equal 26 over square root of 2, because that's how much longer the hypotenuse is than the leg. The problem with this is we can't leave a square root in the bottom here, so we did a rationalized step, multiplying by square root of 2 over square root of 2. All right, so that would give us 26 square root of 2 over square root of 2 times square root of 2 on the bottom would give us a 2. All right, and then the last step, 26 and 2 are both even, so we can divide and get 13 square root of 2 for our final answer there. Next one again is a 45, 45, 90. This is a leg. This is one of the legs, so 5 square root of 2 would be both of these sides. We're going to the hypotenuse because the hypotenuse is that longest side. We're going to multiply by square root of 2 in this situation. So this time x is equal to 5 square root of 2 times square root of 2. And what happens there is when we get 2 square root of 2's in a row, that's like square root of 4, which is 2. So really they're asking for 5 times 2, which is 10. X is 10. All right, third one here, number 13. This is a 30, 60, 90. So now the rules are different. It's not square root of 2 anymore. We need to know the hypotenuse, the short leg, and the long leg, some things to label. So to get from 12 to x in one step is messy, so we're going to go through the shorter leg. The hypotenuse is twice as long as the short leg, so the short leg is equal to 12 divided by 2, or 6. And then the trick to get from the short leg to the long leg was to multiply by square root of 3. This is where the shortcuts are really nice. If you're keeping simplest radical form, we're just going to put the square root of 3 and attach it to the 6. Okay. Moving on to the rest of 8-2. Let's see, 14, 15, and 16. If we have the legs marked as congruent, then we can say that they're the same length. The legs are the same length. All right, so I'm going hypotenuse back to leg this time, so it's another divide by square root of 2. So x is equal to 6 over square root of 2. Rationalize step. We have 6 square root of 2 up top. We have 2 on the bottom. 6 and 2 divide to make 3 square root of 2. That would be x for number 14. Number 15, we have a 30, 60, 90. So get your short leg labeled, your hypotenuse, and your long leg. All they want us to do for this one is get x. The hypotenuse would be 10, because that's a multiply by 2 situation. Short leg to long leg is multiplied by square root of 3. So the long leg x is just 5, the short leg that they gave us, times square root of 3. All right. Last one, they didn't put an x on. Let's say that we're just finding this shorter leg right here. So we have a long leg. We're looking for the short leg. We don't care, but the hypotenuse is right over there on the top. So we start with a 12. The long leg is square root of 3 times bigger than the short leg. So we're going to divide by square root of 3. And we'll see what happens here. We get 12, x is equal to 12 over square root of 3. All right, which means we're going to multiply by square root of 3 over square root of 3 to deal with how we don't like the square roots in the bottom. So we have 12 square root of 3 up top, 3 on the bottom, and those two are going to have a common factor, 12 and 3. We're going to write that as 4 square root of 3. That's 8-1 through 8-2, Pythagorean theorem, and special right triangles, so 30, 60, 90, and 45, 45, 90. I'm going to stop this video here, and we'll do 8-3 and 8-4 in a separate video.